Good morning, building science geeks. Today is Monday BS, first Monday BS of what will hopefully become a tradition of myself and Enrico and other members of the Emu mob sharing with you some geeky stuff to start off your week. Being the first week of 2022, it is January 3rd today. We thought we would bring up a topic that comes up a lot in the winter when there are extreme weather events. Especially here in Colorado. Last week, we had the worst grass fire or wildfire in modern history as far as destruction of property. And I think there are a lot of families around here and in other parts of the country thinking about their own resilience as they try to rebuild, or if they are in homes that have been cut off from electricity because of rolling blackouts or other things like that. So one thing we want to talk about today that comes up a lot in the Passive House world is the concept of the time constant. And the second thing we're going to talk about is performance gap. So time constant basically is a term referring to the length of time that a building can hold its heat without any additional energy or input. And obviously, for those of you who know about Passive House, that is one of the huge benefits of this standard, is that you can conserve so much heat that is naturally generated within the building envelope that you then don't have to supplement as much, or you can wait longer to supplement more energy in. So for homes that are affected by blackouts during blizzards, for example, if they are built to the passive standard, they're going to have, several days of heat stored up in that house before it hits freezing. And then, cooking and adding other types of heat can also prolong that. Whereas, code built homes that weren't even built to code or are worse or in disrepair, that first night that it hits freezing, they are going to drop. And one of the practical ways we kind of try to talk about this with our students is our pod workshop. So in our pod workshop, all of the builder students come in, they get to have kind of a hands-on application of the classroom knowledge they've learned about the passive standard. But one of the things we do is each of the teams creates their own little passive pod. And then we have a code pod, a pod that has been built to the 2015 and 2018 ICC standards. And we roll them outside. Hopefully in a Colorado winter, it snows on them and we see how long they hold their heat. And that's like for us to be able to show students, this is how, you can look at a microcosm, of the example of a time constant. And all of the pods, of course, the passive pods usually retain their heat. If we're talking about, we heat them all up, all the pods, the passive pods and the code pod up to 100 something degrees, roll them outside in the snow, assuming it drops below freezing. In many of the examples it has, the passive pods will still hold, in the 50s and 60s as their temperature, whereas the code pod obviously drops right below freezing along with the temperature outside. So that is one example of time constant. The other thing that we thought we'd bring up this week is the issue of performance gap. There's a lot of kind of resistance in the construction industry to the idea of modeling and virtually prototyping buildings prior to building them. And that's really sad because there's a lot of advantage that we can gain through that. The performance gap is the gap between how something has been modeled and how it actually performs. And in the realm of green building, the Passive House standard has one of the smallest performance gaps out there, simply because it does rely so much on that accurate modeling and then building it the way it was modeled. There are very few other standards that kind of really focus on, none that I know of, that focus on the envelope in that way, on performance metrics. So the performance gap is something to look at as well when you're thinking about what line in the sand you want to draw as far as your modeling and your the goals and the objectives that you're setting, because that's what the modeling is it's setting goals. It's setting a target that you want to hit. It's giving you the map, the roadmap to be able to hit that target, and then it's giving the instructions for how to make sure that it's built to that target. and assuming everything goes during the build the way that it should in order to hit the model, which we all know that doesn't always happen, then you're very likely to hit your performance targets. And in the occasions when something goes wrong and you've got to change something on site, that's what kind of leads to some gaps in performance. Because the PASPA standards emphasizes so much the process of integrated design and conversation and planning and really working in an integrated way between the design phase and the build phase. That's why there's so little difference usually between the build and the model. The builder really needs to have the model in mind. The modeler needs to know what the builder's got in mind. And there needs to be good communication about that. So there are your 2 vocabs for the week: time constant and performance gap. Please let us know if you have any requests for next week of things that we can go over. Thanks.